The universe is 13.8 billion years old. It contains somewhere between 200 billion and 2 trillion galaxies. Each galaxy contains on average 100 billion stars. Around most of those stars, there are planets. Around a significant fraction of those planets, there are conditions that scientists consider broadly compatible with the chemistry of life as we understand it. The numbers are so large, they stop meaning anything when you try to hold them in your mind. So try a smaller version. Our galaxy alone, just the Milky Way, just our one unremarkable spiral galaxy among 2 trillion others, contains somewhere between 100 and 400 billion stars. Researchers estimate that there are around 40 billion Earth-sized planets in the habitable zones of their stars in our galaxy alone. 40 billion planets where the basic conditions for liquid water and carbon-based chemistry exist. And we have heard nothing from any of them, ever. In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory when the conversation turned to a recent flurry of UFO reports in the news. The discussion moved to the general question of extraterrestrial life, whether it existed, how common it might be, whether contact was possible. Fermi listened and then asked a question so simple it took decades to fully appreciate how devastating it was. He said, "Where is everybody?" That question, 3 words, asked over lunch by a physicist who would be dead 4 years later, became one of the most profound unsolved problems in all of science. It has a name now, the Fermi Paradox. And the more carefully you examine it, the more the silence of the universe begins to feel like something other than an absence. It begins to feel like an answer. The logic runs like this. If intelligent life is even remotely common in a universe this old and this large, then some civilizations must have arisen billions of years before us. A civilization that arose just 1 billion years before humanity, a blink in cosmic time, would have had time, if it expanded at even a tiny fraction of the speed of light, to colonize every star in the Milky Way many times over. Even without faster-than-light travel, even with long pauses between expansions, even accounting for the distances involved, the math works out to full galactic colonization in a few tens of millions of years at most. 1 billion years of head start, tens of millions of years to fill a galaxy, and we have found no sign of anyone. No signals, no megastructures, no evidence of engineering on a cosmic scale. No response to the radio signals we have been broadcasting into space since the early 20th century. Just silence. Vast, comprehensive, unbroken silence across 13.8 billion years of cosmic history. Where is everybody? Scientists and researchers have spent 70 years generating possible answers to this question, and every single one of them is either deeply strange or deeply disturbing. There is no comfortable answer to the Fermi paradox. Every resolution that has been proposed either requires something very unusual to be true about the universe, or something very dark to be true about the fate of intelligent civilizations. The first category of answers says that we are alone. Not that contact is difficult or that signals are hard to detect, but that in the entire observable universe across 2 trillion galaxies and billions of years, the chain of events that produced intelligent life on Earth happened only once. That the emergence of life, or of complex multicellular life, or of intelligence, or of technological civilization involves one or more steps so improbable that the expected number of times it happens in the observable universe is less than 1, and we are the lucky accident that beat the odds. This is called the rare Earth hypothesis, and it is both the most comforting and the loneliest possible answer. Comforting because it means there is no one out there to threaten us. Lonely because it means the universe, all of it, every galaxy and star and planet and nebula across 93 billion light-years of observable space, produced exactly one mind capable of looking at it and asking, what is it? The second category of answers is harder to sit with. It says that intelligent life is not rare, that it arises regularly across the universe, that civilizations have come and gone throughout cosmic history, and that something happens to all of them before they become visible on a galactic scale, something that ends them every time. Researchers call this the Great Filter. The idea that somewhere in the sequence of steps between the origin of a planet and the emergence of a spacefaring civilization, there is a barrier, a step so difficult or so destructive that virtually no civilization makes it through. The question that keeps researchers awake is not whether the filter exists. The silence of the universe is strong evidence that something is filtering civilizations out. The question is where in the sequence the filter sits. If the filter is behind us, if the improbable step was something in our past, like the emergence of the first self-replicating molecule, or the development of the eukaryotic cell, or the emergence of multicellular life, or of intelligence, or of technological civilization, then we may have already passed through it. We may be among the rare survivors. The road ahead might be open. But if the filter is ahead of us, if the step that destroys civilizations is one that every sufficiently advanced technological society eventually reaches, then the silence of the universe is not the silence of emptiness, it is the silence of graves. Every civilization that preceded us reached a certain point and stopped. The silence is what that stopping sounds like from a distance. What could the filter be? Researchers have proposed many candidates: nuclear war, engineered pandemics released by accident or intention, climate collapse driven by energy consumption that scales faster than wisdom, artificial intelligence that optimizes for something incompatible with the survival of its creators, resource depletion on a civilizational scale, the development of some technology that is catastrophically dangerous, and also, like nuclear weapons, straightforward enough that every civilization independently discovers it before developing the wisdom to manage it safely. The disturbing feature of these candidates is that they are familiar. We have already developed nuclear weapons. We are already experiencing climate change driven by industrial civilization. We are already building artificial intelligence systems whose long-term behavior we do not fully understand. If the great filter lies ahead of us, we may already be approaching it. The silence of the universe may be the universe's way of telling us something about where this road goes, and we may not be listening carefully enough to hear it. There is a third category of answer that is stranger than either of the first two, and in many ways more unsettling. It says that civilizations do survive and do expand and do become visible on a galactic scale, but that we cannot detect them, either because our instruments are too primitive or because they are communicating in ways we have not thought of to look for, or because a sufficiently advanced civilization has no reason to broadcast its presence and every reason not to. This last possibility, sometimes called the dark forest hypothesis after a novel by Chinese author Liu Cixin, proposes that the silence is strategic, that the universe is full of civilizations that have learned, through the logic of their own survival, that announcing your existence to unknown others in a universe of finite resources is the last mistake you ever make. That the correct response to detecting another civilization is not to make contact, but to eliminate the threat before it can eliminate you. That the silence is not emptiness or death, but concealment, and that the civilizations maintaining it are watching and waiting, and that the radio signals we have been broadcasting into space since the early 20th century are exactly the kind of announcement that a universe operating on those rules would punish. We sent our first powerful radio signals into space over 100 years ago. At the speed of light, they have reached roughly 100 light years in every direction. That sounds enormous. It's a tiny bubble in a galaxy 100,000 light years across. Most of the Milky Way has not heard us yet, but some of it has. In 1974, we sent the Arecibo message, a deliberate, powerful binary encoded transmission aimed at a star cluster 25,000 light-years away, broadcasting our location, our biology, our mathematics, and our existence to whatever might be listening. We will not receive a reply for 50,000 years if one is sent immediately, but the signal is out there, moving at the speed of light through space that the Fermi Paradox tells us should be full of something and that our instruments tell us appears to be empty. Enrico Fermi asked his question over lunch in 1950 and died before the field it launched had properly formed. He was not an anxious man by temperament. The question he asked was not rhetorical, and it was not despairing. It was a physicist question, precise, empirical, genuinely curious. He wanted to know where the math went wrong. 75 years later, we still do not know. Every answer we have found raises more questions than it resolves. The universe is 13.8 billion years old and incomprehensibly large, and every instrument we have pointed at it has returned the same result: silence. The most frightening possibility is not that the silence means we are alone. It is that the silence means we are next. That somewhere in the steps ahead of us there is a threshold that civilizations reach and do not cross. That the universe is not empty, but has been emptied. And that the fact we are here, now, asking this question at this particular moment in the development of our technology may be the most dangerous place any civilization has ever stood without knowing it. Where is everybody? Maybe the silence is the answer.